Let me introduce you our article about optimization models for the use of agriculture aviation when performing chemical works. This article made by Abdizhapar Saparbayev, Aiymzhan Makulova, Assel, Kaziyeva, Zaure, Klyshbayeva, and Elmira Saparbayeva. Abstract. The question of determining the need of vehicles from the maintenance of agricultural work is of great national economic importance. Aviachemical method is firmly established in technology of cultivation of grain crops. First of all, this is due to the fact that compared to ground-based methods, the aero-chemical method of chemization of agriculture has a number of technical and economic advantages, including a higher quality and uniformity of chemicals, eliminates mechanical damage to crops, and less dependence on the physical and geographical conditions of the area, allows to obtain significant savings of chemical and fuel, reduces the time of work. Task setting. The use of aircraft fleet when performing chemical works in the territory of Republic and characterized on the one hand by a large variety of types of the works, and on other hand by the uneven intensity of their performance in time and territory. Analysis of basic laws. When constructing and studying mathematical methods of the use of the fleet of aircraft for the performance of maintenance and repair, the following should be considered. The priority of the performance of the aircraft security personnel for which the serviced territory is assigned. Multipurpose use of aircraft to the diversity of types of work performed. The discrepancy of the situation during the year of the peaks of the performance of the HEW in different areas of the service area. The implementation of labor-intensive regulations is carried out at home enterprises. Taking into account the above features, a mathematical model of optimal maneuvering of aircraft fleet on HEW in the context of current planning can be formulated as a multi-index production transport task of resource allocation. Find such a plan of maneuvering aircraft with which the expected amount of maintenance is performed with a minimum of total reduced costs. In this page you can see the economic and mathematical model of the problem. The solution of the problem. The task of maneuvering the fleet of aircraft on HEW in the formulation belongs to the class of linear programming problems. When solving the problem by conventional linear programming methods, considerable difficulties arise associated with the high dimensionality of the problem. When implementing the task, it's advisable to consider the following. In practice, it's necessary to perform calculations on the model of several objective functions. In actual calculations, indexes of types of aircraft, types of maintenance organizations, airlines, and serviced areas don't take all values but only their various subsets. There is a need to solve the problem with the restriction on the fuel resource as whole in terms of management, and sometimes even in the context of individual airlines. The statement of the problem is rigid. A situation of no valid solution is possible. However, this situation can be interrupted economically, as a deficit of the fleet of aircraft or an overestimated amount for work. In order to ensure the possibility of such an analysis, it's better to use, instead of settings, a non-rigid statement with discrepancies in contrasts that may become critical in the calculation process. The need to take these 4 points into account causes the transition in the maneuver dialog complex from using the model in the text model in the so-called technological formulation. Also in this page you can see the calculated ratios. In this page you can see the main resource and technological limitations. In the dialog, complex maneuver coefficients and models are calculated by a specially developed program in the online mode. So far, only the movement of aircraft has been considered, but when performing chemical work, it's also practiced or to move via technical crew while maneuvering aircraft in the serviced territory of Republic. In this page you can see mathematically this problem is written as follows. Solution of the problem. Information support of the task is based on data on aircraft parameters, technological features, or the performance of certain types of HEW, flight distance to the world, etc. As a result of solving the problems of linear programming between 16 and 23, we got not only the optimal maneuvering scheme, but also a number of important matters for the user of technical and economic service indicators. So thanks to the obtained maneuver scheme, the optimal fuel reserves at the aviation enterprises, the deficit and excess of the fleet, the expanded redeployment of the fleet, etc. are easily determined. In this page you can see distribution of HEW between enterprises of Kazakh State Aviation Administration according to the optimal maneuvering plan in the peak period. Conclusion. Out of 18 airlines that serve 19 regions of the Republic, 17 airlines according to the optimal plan perform work in the territory of the other regions and in the area of their deployment. From table, it's clear that the largest amount of aviation is carried to combat with and best ideas. The analysis of the calculation performed by Kazakh State Aviation Administration shows the high efficiency of using optimization method and models for solving the problem of using agricultural aviation in the performance of chemical work. And the partial value of the optimization approach to solving this problem is directly provided by the territorial administration of the GA, fully provided by the calculation technology implemented in the maneuver dialog complex. Thank you for your attention.